That's, yeah. I was going to show that, but you already have it, so I'm not sure about that. Okay. I can show it to you. Yeah. So we are planning a bunch of workshops for this quarter, and some of them are more advanced topics. Next week we're doing an advanced Git workshop. It'll be in the same space. But yeah, so we're all from Titus Brown's group, and we do a lot of training workshops. I'm the training coordinator, so I'm going to organize them all, and Camille is a grad student, so she'll be teaching this one. This is being streamed online to YouTube, and there'll be people watching. You can watch the stream again after this is over, and I will go through and annotate in the description roughly when things start. But that's all I had to say. I think Titus will be here later. Yeah.
All right. So I guess we should just get started then.
Okay. Make sure your microphone is unmuted if you're going to start.
Yes.
Okay, I can't tell that.
Okay. Well, we're going to get started then. Is my screen shared properly on YouTube and all of that?
Yeah.
Everything's set up. I'm making mouth noises.
Yeah.
Broadcast into the world.
No, this one's not showing, but I know it's there. No, because it's not a normal video. Sorry.
You.
Oh. That's weird. On the YouTube channel, it's just, this is what it looks like. It's just your screen.
Perfect.
Yeah.
Okay.
So that's what we're going off of.
All right. So, welcome to the Pydoit workshop. So just for you probably read the little intro page, but the goal of the workshop is just to teach you all how to use the DOIT software. So DOIT is a Python library, and also a piece of Python software that lets you create automated workflows. Okay, good. Luis says that we're loud and clear, and the picture is nice too. He must be. Luis is my roommate, so this is nifty. So see, this is maybe lots of people are actually just watching from home. Didn't want to brave the cold Davis weather.
Pretty brutal.
So what we're going to do in this workshop is we're going to kind of go through a practical example, and this will be a really simple pipeline that downloads some data, creates a graph using Python matplotlib, and then uses a Jinja template, and we'll go over what that means. Uses a template to actually put it all together and create a document at the end. So this is basically if you wanted to make a reproducible paper. So if you were like writing up a paper and you wanted somebody, and you want to be able to put it on GitHub or something and have somebody just clone it and have the whole analysis run itself and spit out a PDF at the end, this would basically give you the very basic framework as to how to do that. So you'll be able to learn you'll be learning how to do both data analysis workflows and reproducible documents. And for those of you maybe who are familiar with our lab, we are pretty big into all sorts of reproducibility and open science. So this is like a double whammy here. So you get to do reproducible papers and workflows. And practical drivers other than ideology are always nice. So for how this will actually help you, you're going to save time rerunning analyses and adding replicates. So if you have some computational studies and you need to add replicates, it's really simple to just add a couple more tasks to spit out a whole bunch of replicates of something. You save computational resources by only running analysis tasks when they're needed. So DOIT will, assuming that you create your tasks properly, DOIT will detect whether they are up to date and refrain from running them if they already are. It self-documents your workflow because it's pretty easy to read these workflows so other people can look at what you've done. It reduces errors because you are very clearly defining and executing your tasks step by step. So you having this reproducible style of workflow really actually helps you to avoid making major mistakes. And of course, it will make you happier and more smug because you can tell everybody that your analyses are totally reproducible and you're an excellent modern citizen scientist. So hopefully, has everybody kind of gone through the setup already? We have Seaborn, DOIT, Pandoc, Jinja2, these Python libraries. Everybody good there?
I'm having trouble with getting on the Mac on the libraries. It's out of date. We'll update it.
Which one is that?
Numpy.
Numpy. Okay. Wow. So that means that you can't get pandas installed?
I'm not sure what got dropped. That's where it failed. Is on a Numpy. You can't uninstall it for you.
Gotcha. Are you using Anaconda or?
No, just use pip.
Okay. Jessica, do you know how to diagnose pip issues? Do you think you can?
So much I can try.
Okay. Give it a try. It's not gonna. It won't be required until a little bit later in the workshop. So maybe we'll be able to work on it like during the coffee break or something. So, all right then. And we have Pandoc installed. That should be pretty easy to install because it just gives you like a DMG or an executable if you're Windows, or Linux. Okay. So let's. As long as you have DOIT installed, we should be set for the beginning here. So let's get started then. So in terms of like what actually DOIT is, has everybody here like used a make file before? Okay, so maybe if you've installed some software on like a Linux machine, you've done something like /configure make install. In that case, you have used a make file before. So make is this kind of the old graybeard of build systems in a lot of way. It's often used to manage like big C++ projects where you have to compile a bunch of things and it tracks all these dependencies and it's a workflow system that's a little more targeted at actually managing software projects. So DOIT is pretty similar to make, except for that it adds a lot of new functionality. So essentially what you have is a list of tasks you'd like to accomplish. And those tasks can either be shell commands or just arbitrary Python code. And then each task has a list of dependencies. And those dependencies are usually files, but they can be other things, which we'll go over. And the tasks have targets. And DOIT will look at all the dependencies and targets and build a big directed acyclic graph is the technical term. Think of it as like a flowchart to figure out the order it needs to execute everything in. So there's actually on the site here, there's a software carpentry has a comparison between make and DOIT on their website, which if you're familiar with make, I would recommend. It's a useful little comparison that can give you an idea of when you should consider using make versus when you should consider using DOIT. Obviously here we're going to encourage you to use DOIT, but for some cases, for really simple things, make might sometimes be better. I use DOIT for most of my things. So we're gonna get started with an example because I always like to just start off with hello world. So here is an example of a Pydoit task. So the task is just a Python function. It starts with task underscore, and that will be important. For the canonical way of running Pydoit, your tasks should all start with task. And then it just returns a dictionary. So dictionary has a couple of expected entries. In this case, we have one that's actions, and that's a list, and then we have one with targets. And hopefully, if you have some basic shell familiarity, you can see that this is actually a shell command. It's just saying echo. It's echoing some text into a file. And then we see here that the target, I guess people online, so I should highlight things. The target, hello.txt, is also right here. So what I'm gonna have you guys do is just create a directory somewhere. That'll be your working directory for the workshop. And then within that, you're just going to create a file called dodo.py. So dodo.py is a DOIT's version of a file called makefile. So if you're used to GNU make, you've probably seen a file somewhere, something like this. You know, it's called something like this, you know, in a directory somewhere. So this is just a file that has a default name that make will look for. For DOIT, it's just dodo.py. So we're going to make a file called dodo.py, and then just put this function in it. And then when you're done with that, we're going to actually run DOIT. So first, just create the file. So it'll be something like, well, you know, I'll call it, you know, Pydoit workshop. I'm going to move into that directory. Of course, you can use whatever text editor that you're familiar with. I use Vim usually. Vim can be a little obtuse if you've never used it before. You can use Nano. You can use any text editor that you're familiar with. Already have like a text editor that they're comfortable with that they like to use. Okay, just, you know, I like to make sure.
Yeah.
Anybody want to have a Vim versus Emacs war? No? Okay, that's good. We'll save that for another workshop.
That's nice.
Okay, so we're going to just take this function. We're going to put it in here. So we have a function. If you want, you can get fancy. You can say, you can do your hash bang, but it's not actually required. What is it? User bin and Python, something to that effect. All right, so this is a very basic DOIT task. And now in this directory, or if you're using Anaconda or something, you probably have some sort of virtual environment, but if you don't have Anaconda, you're not going to have that. So now all we have to do is we run DOIT, and we get some output like this. So DOIT is Pydoit's main application that actually runs tasks. So that's nice and easy to remember. Do it, get it done. And what we have here is one little output, little period, and then hello world. So if you compare this to what the code actually looks like, we see that we have task hello world. Well, as you might have guessed, it took the name from hello world and it outputted on the command line. Now if we run DOIT again, same deal. So there's your basic hello world. Now if you look in here, there's this new file called hello.txt. It just says hello world because it was created by the task. So it's echoing hello world into hello.txt. So this is exactly the same as if we were to just take this command and run it on the command line. Put it in a bash shell, like so. Or it doesn't like the exclamation points or such. So, any questions on that? I haven't done a lot of explaining the actual context here, but you've made your first DOIT workflow. It has one task. Okay. So we're going to move on and actually start off with our example practical workflow. So let's move on to topic number 2. Fortunately, I realized that there's not actually like a home button on the Sphinx pages, the Sphinx documentation, so you have to go back each time, which is kind of annoying, but sorry about that. All right, so we're going to move on to targets. So this lesson is going to introduce our first useful Pydoit task. So we're going to write a task that's going to download some example data, and we're going to hopefully by the end of this understand how targets work. So first step in our pipeline, say we're making a reproducible paper here, and so the first step is probably going to be actually acquire the data. So we're radical open science sorts, so we're going to keep our data freely available for download. So the data that I have provided is in an S3 bucket. If you're not familiar, this is just Amazon's data sharing service. So I have some data in an S3 bucket here. So this is data set of great, this should say importance. Oops. So the greatest data set of great importance, it's actually some data that a friend gave me from a Super Smash Brothers server. So this is really important stuff. And so we could just have the users download it on their own if they were going to run our pipeline. But of course, we're going to automate this process. So if we just did this on the command line using this URL, the command would look something like this. We'd have curl, and then we'd have a link to the thing. And if you just ran that, you know, it would download the file. Voila. ls, and we see we got this melee-data.csv.gz. And so let's kind of break down what the command actually does so that we can get an idea of what the targets are. So the program runs curl in general. So the program is curl. We give it a URL, and then it creates a file. So because I gave it this -o, the big O here, that just tells it to use whatever name is on the server. And so because the file is named melee-data.csv.gz, it's creating a file with this name on our hard drive. So if we were to look at the command as a task to complete, so we want to complete this curl task, we would say that if the file exists already, then we consider the task done. So in DOIT's lingo, the file that is output is a target. So the program outputs a file. That file is telling us the existence of that file should indicate that the task is actually done. And so we're calling that a target. The command itself is the task's action. So targets and actions, the two really basic important DOIT concepts. So following the same form as we did for the hello world task, this is actually what our download data task is going to look like. So what we have here is we have a task. We're calling it download data. And then the actions is always a list. So you can have more than one action per task. In this case, we're just going to do one. And it's just the curl command that we had up here. So we're saying curl the URL. And here we're saying curl the URL. And then our targets is another list. And in this case, there's only one target, and it's just this file, the melee data. Is that clear? A little bit clear? Okay. So we're going to open up our dodo.py again, and we're just going to stick this task in there. So open up dodo. I have an awkward name, but you know. Now I have to. All right, so. All right, so we have this new task, download data. Remember your Python spaces and tabs and all that, so it might, depending on how things are copying and pasting. So now if we run the DOIT command, we should. So it kind of gives us a little bit of our normal curl output. And we get the same thing with the dot and the name of the function minus the task. So for DOIT, this dot just means that the task was ascertained to be not up to date, and then the task was executed. So if you see the dot, it means that the task was run. So if we run DOIT again, we just run it again, we actually see that the task was run again. And so that's not necessarily what we want. And so we're going to, next we'll go over how to actually keep it from running the tasks over and over again. So a little extra info here. We talked about this a little earlier, but I'll just go over it again. DOIT, when you run DOIT, so when you just run the command like this, it's just going to search the current directory for a file named dodo.py. And we have that. But if you were in another directory, You can't find, there's no dodo.py. So you can actually tell it where to look, but in general, we're just going to stick with the running it from the current directory. Like if you were to run make without having a make file in your directory, it would just tell you that it can't find a make file. And then later on in the advanced section is where we're going to go over alternative ways to run DOIT tasks. But for now, we're going to stick with just using the DOIT command. Okay. So does it seem, so targets are, I guess targets are pretty straightforward. It's like, here's the files that the task creates. Okay. So here is a pretty important section. So we're going to go over dependencies, which are kind of the partner of targets, and then the up-to-date attribute. So as I pointed out just a bit ago, when you run DOIT for the second time, still re-downloads the file, runs all the tasks again. And we don't actually want that. This file could be huge, right? What if this file is like some genomic data or some, 1,000 brain scans or something? We don't want to download it again. So there's a couple ways for DOIT to actually handle this sort of whether it's considers a task up to date. So one is through dependencies, like file dependencies, and the other is through an up-to-date function. So file dependencies are pretty intuitive. Thanks, Facebook. File dependencies are pretty intuitive. It's just you give the task a list of files, and the task depends on those files. And then if any of those files change, the task is just rerun. So unfortunately, the command that we needed to start with, this download command, adds a little bit of complexity already because it doesn't depend on any files, right? The URL isn't really a file that DOIT can go access and check on. So there's another really important attribute for DOIT tasks called up-to-date. So up-to-date is just another entry in the task dictionary, and we see here. And it's either a list of Booleans, so just like true, false. So you could just say up-to-date is true. It's a list of callables, so like functions or classes that have the underscore call method on them, but in this case, just functions, or strings that specify shell commands. So if any of those up-to-date items evaluates to false, so if you had some function, if you had like, a function that was like, this would evaluate to false every time you call it, right? So if the function evaluates to false, or if the value is just false, or if the shell command returns a 1, anything except for a 0, then the task is run. So that's a typo that somebody remind me to fix that later. That is an important negation that should not be there. So for the download task, there's actually a really nifty function built into DOIT. And so this is just a function that is in the library. And what it does is it just makes sure that the task is run once. So it's called run once, and we can just import it. And then we can add it as the up-to-date parameter. So if we do this, open up our dodo again. We want to import that. And then we can do this. Just add another attribute to the dictionary. We just give it the function name. So hopefully, we've got intermediate Python knowledge, so we know that we can just pass functions around in Python, right? I can give a function as an argument to another function. I can have dictionaries point to functions. So we're just saying up-to-date is going to access this function, and when it comes time to check whether the task is up to date, it's just going to run this function. So all this does is really just kind of keep a little count of whether the function's been run before, whether the task has been run before. So now, if we undo it again in this directory, we actually see that it runs once more. And then if we run it again, the download has this little dash dash. And so the dash dash, let me make this a little bigger. The dash dash means that it was determined to be up to date and it was not run. So you might be wondering why we had to run it twice. So under the hood, if we actually do an ls-a to look for files with dots, we see that there's this .doit.db. So Pydoit actually keeps a little file in the directory that it's running in where it keeps track of all of the tasks that are being run. And so that file, depending on what the up-to-date method you're using, that actually kind of keeps track of the metadata. So this will have like the like MD5 sums of the files that it depends on. So it can actually check if the file has changed at all, as opposed to if it was just, you know, touched at a different time. It'll also keep track of things like whether the tasks have changed. So we had to run it twice here because we actually changed the up-to-date parameter, and it hadn't kept track of it before until we added the run once function. So just to look at that again, you should have a function that looks something like this. Okay, so we mentioned this earlier. So by default, the task name, download data, comes from the function defining the task. You can actually also define your own task names by adding a name entry to the task dictionary. So if we wanted to call the function something, the task something else, we could actually do something like this. Our own name, and then when I run DOIT, it's supposed to be, yeah, sorry, I guess well, we'll go over the details of that a little later because it's more important for something called subtasks. So sorry about that, folks. Okay, so this is an important little section that trips people up a lot. It tripped me up a lot when I was first trying to learn how to use DOIT. So the system for determining whether a task is up to date is a little complex. So the documentation has even more information on this. In fact, DOIT's documentation is really good, which is quite nice. So it provides a list of conditions where a task is not up to date. So if any of the up to date items evaluates to false, then it's not up to date. And so what it means by that is if I had this, for my up to date items, the task is now never going to be up to date. So it's basically just checking if any one of these list item updates to false. So I'm not sure why exactly you would do this. It's kind of implied by if you don't have up to date at all and you don't have any file depths, then this basically is always false. But if you wanted, you could just tell it to always be, to just never be up to date. You can actually do this too, which would tell it to only run if the target doesn't exist. So if you got rid of the run once and just had true, actually it's just gonna run, it'll work really similarly to run once. So the other way is if a file is added to or removed from the file depths, which we're going to introduce here in a bit, but those are your file dependencies, so files that it depends on. So if that list is changed at all, it's no longer considered up to date. If a file dep changed, so that means that one of the files that it depends on changes, and that's why it keeps track of the MD5 sums of the files in that database. It'll be not up to date if a target path does not exist. So if one of the target files just isn't there, it's no longer up to date. And if the task has no file dep and an up to date item equal to true. Okay, so yes, so the last of these is actually why we have to include an up-to-date entry in our download task, because it has no file dependencies and it's just always going to be considered out of date, even if the target exists. So you can maybe kind of guess what happens. You can experiment here a little bit if we were to change the up-to-date to true or false. So let's just play with that a bit. So what if we do false? I kind of talked about that already. The up-to-date is false, and we run do it again, and re-download the data. And just no matter how many times we run it, the data is just going to be downloaded again. So what if we were to change it to true? Any guesses?
So the file already exists.
Yes.
So run.
We've got a shouldn't run. That's correct. So it seems a little hacky, but it's pretty useful. So I actually use that. I have a piece of software, an application that I write, that I maintain, that actually uses DOIT in the background to manage. It's a bioinformatics, it's like an annotation pipeline. And so it relies on these giant databases that you really, really, really don't want the user to have to download more than once or re-download if they already have them. So for those cases, I just do the up-to-date as true, so that if it finds the database already, it doesn't re-download it. So this can be pretty useful, especially when you're dealing with like big data or standardized databases where you're expecting the user to have one already. Okay, so questions on up-to-date. Now that was a lot of little conditions we just introduced. Okay. Hopefully nobody on YouTube is too confused.
My people.
All right, so we know a little more about how tasks are considered up to date. So we're going to introduce a file dependency. Arguably, file dependencies are even more important than the up-to-date parameter. But seeing as we had to download our data before we could do anything else with it, we're introducing the file dependency second. So the file that we downloaded was a gzip archive, so just a compressed archive. And so we'll want a task to extract that. So the command we would run in the shell would be something like gunzip, just gunzip the file. So if I were to just run this, I would have, say, gunzip, and now we just have meleedata.csv. And so if we kind of break down what's happening here, we have a target, like before. It's the file that's created, meleedata.csv. We have the action, which is just running gunzip. And then we actually have a file dependency. So running this command relies on this file existing. So if this file doesn't exist, we can't do this task. So that is a file dependency. So we're going to add this task to our do, our awkward name file. Okay. So there's actually two things introduced here because I'm fiendish like that. So we have this new task, gunzip data. It has actions, which is to just do the gunzip targets like before. So there's two new things. The first new thing here is this file dependency. So it's another list. There's only one file dependency here, so it's just a list of one item. And that's saying we need this file to exist in order to run the task. You'll notice that this file dep matches up with this target. And so this is allowing DOIT to actually kind of draw a line between these two tasks. It's saying, not only is it saying that that the gunzip task depends on this file, it now knows that the gunzip task depends on the download data task. The other new thing is there's this nifty little built-in string substitution. So these are automatic variables. And so DOIT likes to try to make things really simple for us. So it'll actually do these substitutions for us. It has these built-in variables. It knows what dependencies is, it knows what targets is, and it'll actually replace these in this string for us when it executes. That way you don't have to write out a whole bunch of the same file names all the time. Reduces your chances of making mistakes. So now we've got that. If we run DOIT again, we've got this gunzip data now. And then of course we run it again, it doesn't run either of them. It reran the download because we messed with the uptodate parameter. And now we've got the .cv.csv.gz and the .csv. Here's a little gotcha. For this one, I did the gunzip-c and created the file explicitly. So I ran it like this. I did melee data.csv.gz to melee data. The reason I did that is because I don't actually want to, for now, I don't want to delete the gz file, because that can start to trip up DOIT's file dependency system. So if you just do, so you might be familiar, if you just do it this way, it's going to get rid of the original gz file. And so to let DOIT more easily keep track of everything, I just did it more explicitly. There's ways around that. For one, you could just do the download and the unzipping in one task with 2 actions. But for now, we're gonna do it the more verbose way. Okay, so any questions? Yes.
So you have file dependencies, but then in the variable names, you just have dependencies. So are there other types of dependencies? And
Yes, that's a good question. So
Repeat it so online we can hear what the question was.
yes, so the question was, we have file dependencies. And then when we do this, the variable names here, we just have dependencies. So the question was whether there are other sorts of dependencies. The answer is yes. There's also a task dependency. So there's actually a task dep attribute that we can add. And that just, the task dep is a little, it's counterintuitive at first, because all it really does is enforce order. So for a task dep, the up-to-date status of the task that it depends on doesn't affect whether the task is up to date. So it might still rerun every time. And so the reason this is just dependencies is because there's not really any case where you would need the name of the task on the command line. I mean, I can think of some really edge cases, but in that case, you could just do some like string formatting here. So yes, there's also the task dep. All right. And we got so now 7. We're getting through pretty fast.
Yeah.
Ending
early is okay.
Okay. Does anybody want to break for coffee or anything? Yeah.
I have a question.
Okay.
But specific to my situation, so.
Gotcha. Okay. So do we want to?
Yeah, we can say maybe a 12-minute break. We'll start again at 10:20.
Yes. Okay.
Maybe put that on your screen. So
Yep.
people know. And it's secure, right? If you have not registered. It works.
Okay. Cool. I guess I'll mute
And we
this.
can mute now.
Welcome back to the Pydoit workshop brought to you by the Dib Lab. All right, folks, we're gonna get moving again. All right, so we just went over dependencies and task status. So the brief recap, we went over up to date. So this is just the parameter to say whether a task is currently up to date. There's this nice long list of conditions under which a task is up to date, and then more directly, there's the Pydoit documentation has this list and lots of other information. Also, I guess this is kind of important. This is highly recommended. DOIT is really, really, really well documented. I need to send the developer an email or something because I very much appreciate this software. So it's very well documented. Very well tested and everything. So if you have questions, additional questions after the workshop is done, there's a nice big long list of tutorials and documentation for everything you can imagine to do with DOIT. Yeah. So, and then we went over file dependencies and we talked about task dependencies just a little bit. So moving on then. Our next section, Python tasks. So at the beginning, I had mentioned that tasks actions could either be shell commands, which we've now done a couple of, or they can be arbitrary Python code. So we downloaded the data and we unzipped it, unzipped it, likes. So both of those tasks are simple shell commands. Of course, we can also do the Python code. So we're going to take advantage of that to do some quote-unquote analysis of our Super Smash Brothers data and generate a plot. So the Python tasks are defined pretty much in the same way as any other tasks, but this time the actions entry is going to be a function name instead of a shell command, instead of a string. So this might be, if you're at an intermediate level of Python, this might look weird at first. In Python, you can define functions inside of functions. It's beyond the scope of this workshop, but this would be a closure. This is where we're defining a function, and well, it'd be a function. It would be a closure if we returned this function, but we defined a function inside of this function, and it has access to any other variables that are defined in the namespace of this function. So we're gonna put our action function inside of this function because that just keeps everything kind of in the same place and makes things a little easier to follow. So we have the whole function, the task plot heat map, which is actually the task, and then within it we have this do plot, which is actually the action that is going to be executed. So if we look here, it just does a couple of things. For those of you who are familiar with pandas, we've imported matplotlib, pandas, and seaborn, which is a little plotting utility that takes advantage of matplotlib. We're just reading the data in, as reading the CSV file into a data frame, and then we're using the seaborn's cluster map, which just makes a little heat map and a dendrogram, and lets us pretend that we did real analysis on the data, and then it's got lots of fun little parameters, and then we're saving the figure. So important things here. We see that the Python action takes two parameters. It takes file dep and targets. So those should be familiar. It should be familiar because, of course, they're the same as these attributes. So these behave really similarly to the automatic variables that we used earlier, only this time the actual Python objects are passed to the Python action. So if we name our arguments to this function the same as file dep or targets or whatever, it will just pass these actual Python objects to it. So we can really see that in action here when we do this. So we're actually accessing file dep 0. So we're accessing it as a list. And the same here for the targets 0. So We're just doing 0 because there's only these are lists of 1, so we're just working on the single item list. So a couple of important things here as to how this kind of works in the background. This function is not actually executed immediately. So this function is only executed if the task is out of date, right? So when we first go through and make all the tasks, it doesn't just run this function right off the bat. And so it's easy to start getting confused in these when you're doing Python actions like this, and to start trying to do like actual like work outside of this function. But if you try to do real work outside of the action function, it's going to execute when the tasks are checked for whether they're up to date, as opposed to when they execute. So there's kind of these two phases. There's task loading, where it looks at all of the task functions and checks what the functions are and whether they're up to date or not. And then there's the execution stage, where it actually runs the tasks. So that's an important distinction to make. The other important thing is that because these are Python objects, remember that everything in Python is an object. So these are references. So if you start modifying this list within this function, you can actually change the file dependencies and targets and everything while the task is executing. If you really know what you're doing, and if you do it a lot, that can be useful because you can edit things on the fly. If you're a beginner, that can be very bad because you can really mess up all of the dependencies and everything. So it's probably best to just, while you're starting off, to just keep things read-only. Okay, so we're going to add this function now to our do. Of course, just like our others, we have this. We have a file dep. We're depending on the CSV. This is the gunzipped CSV. And then we have a new target, which is the heatmap.pdf. So we're just going to save the heat map as a PDF. And then you can see here the actions, instead of being a string, is actually just the name of this function. So the actions are do plot. Okay, so now we're going to run this. I actually expect that it's not going to work because I think I have a typo, but we're about to find out. Yes. So what did I do wrong? Do plot arguments. Okay. I just need to check something real quick. Okay, so there are, apparently I updated this in my example file, but didn't update it in here. There's actually 2 typos in here, so one is that the name of this should not be file dep, it should be dependencies, just like with which makes sense because it's the same for the automatic variable. So this should be dependencies, and then this is now wrong as well. So dependencies, and it needs to be cast into a list. I'm sorry about that. That was the thing I fixed and forgot to fix in next. So I'll make sure to, that'll be another thing that I fix. So dependencies is the automatic variable, matches up with the one for string substitution, and for reasons which aren't entirely clear, in the back end, the way the implementation works, dependencies is actually set up as a set. So this should be dependencies as a set instead of a list. So sorry, you have to do the list dependencies like this and then access item 0. So I know that's a little weird, but DOIT has decided that there's no ordering inherent to the file dependencies, so it made them into a set. And you cannot access sets with this notation. The only way you'd be able to access it would be to pop an item off of it, but we don't want to modify the set in place. So we're making it into a list and then grabbing element 0. And then you get to see me do some on-the-fly fixing of things because I really want to make sure that this is all good. The dependencies list dependencies 0. Perfect. Fix typo in task F. Okay. So we fixed the website on the fly. You actually might notice that I made a do-do for updating the website itself, so that's fun. Seemed only appropriate. Okay, so let's see. So now we're going to run this. So if you didn't manage to get matplotlib and pandas and everything installed, this isn't going to work because it's not going to be able to find the imports. So hopefully we'll be able to take care of that. So we see that we had this function plot heat map. It ran. And you also notice it's still running hello world every time. You can get rid of the hello world task if you really want, or you can just have your pipeline saying hello world at the beginning. Doesn't really matter. And I guess I can actually use that as another example. If there's in the absence of any dependency information, so hello world has no dependencies, it has no task dependencies or file dependencies or up-to-date info. So in the absence of any of that, tasks are just executed in the order that they're encountered. So hello world happens to be the first task in the file, so DOIT just executes that one first. All right, so if I ls now, you can see that we've got this new heatmap.pdf. All right, so let's take a look at that. Hopefully it looks nice. Heatmap plus dendrogram. So unfortunately, this is really ugly. Seaborn has a regression. So if you don't know what regression is, it means that there was something that was working and now it's not working, where the labels get all messed up. So I just did this in 2 steps in the tutorial because I'm sometimes a perfectionist and I didn't want to confuse you by introducing this new, like, confusing looking code. But this will help illustrate 2 things. So we're going to fix it by adding this ugly looking matplotlib code, which is going to rotate the labels for us. We will also serve to illustrate something else. One that I should fix my Vim shortcuts. Okay. So we've added this new code to the task. All right, so what would you expect, without reading ahead, what might you expect to happen here when I rerun this? Do you think the task is going to run again, or do you think it's going to just still count as up to date? Any guesses? You might imagine that the task would run again because we changed the task, but it actually does not. So there's actually a specific section in the documentation defending this design choice because people complain about this a lot. But the do file itself is not a file dependency. So if you change the do file and you don't change the uptodate or the file dependencies of any tasks, it will not rerun the task. So that's an important consideration. And he has some good reasons for not doing that. It could add some complexity and screw some things up. And I'm not going to get into why, but if you would like to, there's an area in the documentation that defends that decision. So it's important to realize that if you change your actions like this without changing any dependencies or anything, any targets or dependencies, you will need to do some extra work to make the task rerun. So in this case, you can just remove the heat map PDF. Now if we run it again, target didn't exist, so it's not up to date. And now it should look pretty. Okay, we've done some real data analysis of our important data set. We've made this obtuse looking heat map. So for those of you who care what's actually happening with this data, all these are just for each character, I have the win ratio versus other characters. And then I've just clustered it by the vector of win ratios. So if you're a real video game nerd, you can like look at this heat map and go compare it to all the ladder rankings and the tournaments, and it actually matches up surprisingly well. I was pretty happy. Like they have like 4 categories of characters that a whole bunch of geeky video game types have clustered together based on all sorts of things, like all of their moves and how often they win and how they win tournaments and everything. And you can pretty closely reproduce that just by looking at only the win ratios and just clustering them together with a basic like distance metric. So I was kind of proud of that. But the actual data itself isn't really that important in this case. So science things. Okay, so moving on. So it said here it didn't run, because as far as DOIT is concerned, nothing changed. So you have to rm the PDF file and run DOIT again. So that introduced, okay, so that lesson introduced a lot of new stuff. Is there any questions? Okay, that's fine. And I can actually, at the end here, I'll add in a link to the complete pipeline file for those of you who will want to, who are come in late or whatever.
Or who watches it later, yeah.
Yes. Okay. So we're going to move on to the next section, and this is cleaning. So in the previous section, we changed the heat map plotting function, and then we had to manually remove the target. Right, so we changed the function and it didn't rerun, and then we had to rm the heat map file, and in order to have it be regenerated. And it'd be nice to not have to do that, right? So the way that we can manage this and any sort of cleanup of our pipeline is via the clean attribute. So you might guess that the clean attribute is a function which cleans up after the task. So this is kind of like if you're like you're using make. You've probably seen this if you've followed some directions on the internet for installing things. If you say like make clean, it does something to remove a bunch of files. Well, this is basically the same thing. This is DOIT's version of make clean. So clean is another attribute, kind of like UpToDate, and it can take functions just like UpToDate, and it can also just take a shell command like UpToDate and like your actions. So what's nice here is you see that a lot of things kind of behave the same between different attributes. So actions and targets, all these things can be either shell commands or Python functions. So of course, the developer, DOIT's developer, pretty rightly identified that cleaning the targets would be something people would want to do a lot. So just like with the run once uptodate, he included a function for cleaning up the targets as well. So if you add that in, add in the import, like so. And then if we do something like, and we can just add this clean attribute. So let's add it to our download data task. So something like this. Now if we say do it clean, oh, apparently I've been crossing wires in my brain. We don't include things in Python, we import them. Okay. Do that again. We see from the download data, it said I'm executing the Python function clean targets, and then it gave us some extra output and said that it removed this file. All right, so now if I look here, that file is no longer there. That's because we added it to the download function. So now if we run do it again, it redoes the download. That's strange. Didn't redo the gun zip. I love finding bugs in my code on the air. It might be because we did this. All right, well, that's something I'm going to have to figure out because that's not right. It's very odd because it worked properly previously. Okay, so what should be happening here is that the gun zip should also be redone because it's depending on this target. I'm not entirely sure why that did not work. Target. Well, maybe somebody on the air will see what I did wrong and can tweet at me and chastise me for not properly testing my materials. But we're going to keep moving on, and I'll try to fix that during the next coffee break. Okay, so what should be happening is all the tasks should be rerun because they depend directly on the downloaded data file. I have one more trick up my sleeve here because I would really like this to work. Now if I do it clean, it's going to download that, and what happens if I undo it again? No dice. Okay, well, I'll figure that out later. Okay, so another note here is that you don't actually have to import clean targets directly. This is apparently a little bit deprecated. The function still exists, but you don't have to import it. If you just pass true to clean, it does the same thing. It just removes the targets. So it's really common to just want to remove the targets for the task. So this just does that for you. But if you would like to remove the targets and do something else to revert your task, so say you have two functions you'd like to run, then you have to include clean targets. So if you wanted to do something like actually I'm going to show you how to do that now. So clean can also just be a shell command or a function defined by the user. So let's say we wanted to inform the user where the file that they deleted. So we're going to add a couple more things here. We're going to actually include the URL as its own little variable here, because it's always nice to separate out things like that. So now we're just going to have this global variable at the top saying what the URL for the data is. And then we're going to add this extra function inside the download data task. Oops. Hey. We've added this. Now we have to make one more little modification, which is that we added this data URL, and so we're trying to remove some redundancy here. So now we have this. So we're just going to say do some Python string formatting, do it this way. And finally, what we're actually trying to show is that I'm going to add this print URL as a second clean command. So if this were on its own, if we were just wanting to clean the targets, we could do it like this. Right? But because we've added this second function here, we have to do the clean targets explicitly. Okay.
Or maybe you have a fix.
Curious. Okay, so now if we do it again. Okay. All right. I think there might be something wrong with my DOIT version. Because apparently I'm out of date with the documentation. Sorry about that, folks. Okay. So if we run DOIT, we get that thing as we're run. And now if we do clean again, we get this extra little output. So it runs clean targets and all these guys. And then for the download data, we added this extra print URL function, and it just executed that function. Very strange. Boy. Yeah, okay, that's probably very afraid that I borked my installation on here. That'd be bad. So for those of you actually following along, just a little task here. You can go on and add clean attributes to all the currently defined tasks. So I know a couple of people have had installation issues, so maybe you won't be doing this. But if you're following along.
You give it a couple minutes. You could give it a couple minutes.
Yeah, so we're going to give 5 minutes to go and add clean attributes. I'm going to see what Lex told me on Twitter. Yeah, this is an idea, but I'm actually not positive that that's what the issue is. MD5 sum didn't change. That actually might be, I think that is actually it. I think that actually is it. It's cool though. In the past, it has not always done that properly. Thanks, Lex. Now, of course, if I were to remove the .csv, it should do all the heat map stuff again. Yeah, see, no, that's, yeah, downloads the data does again. Yeah, okay, cool. All right, so we've just demonstrated that DOIT is in fact working properly and not re-executing tasks because the MD5 sum of the file is the same. You can actually force, so something like make actually uses the timestamps on the files to decide whether they've changed, and DOIT does not do that. It uses the MD5s. You can actually force it to do that. I can't remember. It's something, it's not something I use very often, but if you say, let's see. Oh yeah, something like check timestamp. Yeah, so there's a way to tell it to actually do an update even just for the timestamp instead of for the MD5. So yep, I agree. That's what it is. Okay. It's a futuristic class.
Very interactive.
Yes. All right. So if we were we're adding clean attributes, remember. So if we do like we go and add this to the final one, we can say clean is going to be clean targets. We'll even add it to hello world because why not? Oops, clean targets. Then just because we're really fleshing things out, we'll actually keep our hello world from saying hello every time, just like we did before. So hello world should only run once. Now if we say do it clean, find out if I had any typos. No typos. Run do it again. And it reruns all the things because they were all cleaned. I get this because if you have this, just ignore it. It's because my version of matplotlib is pretty new and Seaborn has not caught up with the new version of matplotlib. So it's just a deprecation warning. There's a way to silence those, but it requires adding some boilerplate that we don't need to go over now. So just ignore it. Okay, so sorry we had a little, some rockiness there. Is everybody, do you have any questions, any comments, concerns? Please.
Sorry, I'm super behind. So I'm like still trying to install stuff.
Okay, it's no problem.
I can't run curl, so I can't download it.
I don't know what the Windows version of curl is. Does anybody know what the Windows?
Based on a quick search, it seems like a problem. It's a problem getting a secure site. It's a common problem.
That's fun. Well, maybe somebody else. I don't use Windows at all, so maybe somebody else can figure that out.
Yeah, I'll figure it out later. This is still understandable.
Okay. All right, so then we're going to move on.
Plus you can watch later.
Yeah, I
Exactly.
fully intend to do it.
No, just yeah, don't think I'm right.
Yeah, so Windows users, you might be having issues because Windows adds some complexity here, but you can always use Sigwin or some such. Okay, so finally we're going to introduce subtasks. So we've defined tasks that download our data, we're gun zipping it, and we can plot it. However, our original goal was to create a publication pipeline. So we're going to get on with that. So this lesson is going to introduce actually a couple things. For one, we're introducing the actual idea of subtasks, and it'll also help you out a little bit with doing these reproducible papers. So the file defining our paper, I've chosen to write in Markdown. So maybe you may or may not be familiar with Markdown, but Markdown's it's a nice little markup language that lets you define plain text files, and a lot of sites are moving to using that for rendering. So if you use like GitHub at all, GitHub's comments have Markdown syntax. So a little example. This is a piece of software of mine. So if I were to file an issue on GitHub, I wanted to show you how Markdown works. Hopefully this will work properly. Like you can, there's some simple syntax that you can use. So you can, so it's just like a hashtag is the title, 2 hashtags is like a subtitle or section headers, and I say, you know, some test stuff. And then I can say, you know, we have, you know, another section, and another. Hopefully this works with issues, but if we do this, yes. So it actually gets rendered kind of like with HTML. So using some of these other libraries and using Pandoc, you can actually, the brave amongst you can actually use Markdown for writing papers instead of something like LaTeX. So for now, I'm just going to use it because it's a simple way to, where we don't have to write LaTeX in shop, because I'm not quite that self-loathing. So, all right, so that's Markdown. Okay. So eventually we're going to use Pandoc to actually compile the Markdown document. But before we do any of that, we actually want to add our image file into the Markdown document. So, and any other information we want. So we could just include them directly in the file, and we could just like hard code the paths to our data. But I just want to show you how to do this on the fly dynamically. So we're going to use Jinja2. So Jinja2 is a templating library. What that means is that if you give it a text file that has some simple syntax in it, you can find and replace information into the file. So seeing as this is a course on Pydoit and not exactly on Jinja2, I have written a template for us already. So we're going to download that, and we're going to write a Pydoit task to download the template. And so, of course, we already have a task for downloading things. So it'd be nice to reuse that. So surely there's the task we already wrote must be capable of downloading other files, and yes, it is. And the way we can do that is using subtasks. So here's an example of a subtask. So what we've done here is we have our normal task definition, but we've actually defined the task as a generator function. So see, we have this yield keyword. Unfortunately, for some reason, I couldn't quite figure it out. Sphinx was refusing on a couple of my text, my code boxes aren't doing syntax highlighting properly, but that's okay. So you have the yield keyword here. So that makes, hopefully you've seen this in Python before. When you have the yield keyword, it makes it into a generator function, which just means that you can loop over it essentially. And so what I've done here is I've changed the data URL variable to be data URLs. Oops. Which is just a little list. And it has this, we've added a second item to it, which is our template. And then the download task just loops over that list of URLs and yields a task dictionary for each one of them. So what I'm going to do here is, because I'm not live coding everything and I'm cheating a little bit, I'm going to do some copy pasta. So, and then we have to update the data URLs, like so. And I guess Michael's watching, so we better make this PEP 8. Okay, so Now we have data URLs, which is just this little list. And then our download data is looping over those URLs. And then there's one extra thing we've added, which is I have changed our clean, where we're printing the URL. It's taking a parameter now. So down here, we're giving the function as a tuple. So the first element of the tuple is the function itself. And the second element is a list, which is the list of parameters that get given to the function. So this is actually the same syntax you would use if your Python action, if you had a Python action, right? So I know this is kind of got a lot of parentheses and stuff hanging out next to each other. So maybe I'll just like this. So see, we have the actual. This is the item in the list. So first element, name of function. Second element, list of parameters. And now, and here's where we're also, remember we talked about name earlier. This is the case where you need to use name. Because if you were to keep it, if you didn't have the name, you would essentially have two tasks named download data. And the task names need to be unique. So what I've done here is I've given it a name where it's just download and then the target. Okay. So now if we run DOIT, I guess I forgot to import something. Ah, yes, there's this up here. So don't forget all your imports. I'll put that up at the top. Import OS. Here, so we're using os.path.basename. Now we download data, and there's two download tasks. Our melee data, and then our template. Hopefully, there we go. So now, okay, so I know that was a lot of stuff. Yes.
On your on the name parameter.
Mm-hmm.
So that one doesn't need to start with task. You had said earlier that all of the functions need to start with task.
Right.
Is this because this is not actually a function, or?
Exactly. So any function, any task function has to start with task.
Okay.
Because this function, you're talking about like this one? Oh, I see.
Yeah, right there.
Okay, so you mean the name of the function. All right. So yes, so that's a subtle distinction. So the name of this task is actually just download data. And so,
Okay.
right, so when you run DOIT on the command line,
Mm-hmm.
it goes through this file and it has like a regex that it uses to match all the functions that it wants to, that it will consider tasks. So if it starts with task, it says, you're a task function. You must yield a task dictionary. As opposed to here, the name is just, the name is just, we're explicitly setting the name, right? So that's why it doesn't say download data anymore. It just says exactly what we've told it to say.
Okay.
Okay. We see here, we've just got download data, and the name is actually the name of the subtask. So it says download melee-data.csv to document.md.tpl, and then that's a subtask for the main download data task. And so we could essentially now, with this, you could basically add, because of the way we set this up, where we've got our target is just based on the URL and everything. If you wanted to add a whole bunch more files to download, all you would have to do is add more stuff to, add more things, more URLs to this list, and it'll just download all of them. So if I wanted to, let's see, if I did something like what's a file I can add to download?
So if you had a spreadsheet full with URLs, you could scroll through all of them and add them to that.
Yes,
Cool.
exactly. So if you had like a CSV file, whatever, you could just download all of them and add them directly. So here, if I want to add another thing to download, here's a good question. Gonna add another thing to download. I'm gonna get kind of meta here and download something from our own thing. And now if I do it, it'll hopefully, now we've added a third thing. And so, yeah, so the question was earlier, for those who didn't hear it on air, was you could, in theory, you could just loop over the rows in a spreadsheet and just download all of the files from the spreadsheet using this. Okay. Back to subtasks. Okay, so just to go over that again, we're using the generator object instead of just returning the dictionary. So that's the yield keyword. Yield keyword makes that function become a generator. Hopefully, we got intermediate Python experience, so we know what generators are. If not, generators are very useful, and I highly recommend looking into them more. So for Pydoit, specifically, that just Pydoit knows, it can say, oh, cool, this is a generator object, so we're just going to get multiple tasks from it. And we've added the name attribute. Okay, so we've downloaded the template file, hopefully, and let's just take a quick look at what the template file is so that it's not pure magic. So if we say it's the metadata.document template, this is kind of what a template might look like. It's a normal markdown file with some metadata at the top, except for that I've got these little double braces in here. And so that's the syntax that Jinja looks for to substitute things. So author, date, and then down here I've got the heat map file name. And then I've got a bunch of fake sciencey looking mumbo jumbo here to make it look like it's a paper. For those of you who care, Sakurai was the guy who made Super Smash Brothers. It seemed only appropriate. So, science stuff, quote unquote. So this is mostly markdown syntax except for these little, except for the little curly braces that we've added. For the next section, we're going to add one more task. So this is where we're actually going to take that template and fill in all of those curly braces, all those curly brace attributes, and build a real markdown file. So hopefully you have Jinja 2. Add that import. And then at the end, we're going to add this nice giant task. It's not actually that giant, but it looks bigger compared to some of our other tasks. So what do we have here? So what this is doing is it's another Python task. We've got our normal layout here, name of the task plus the name of the task. We're defining another Python function inside of it. That Python function takes targets, which means that it'll take the list for its own targets. And this time what we're doing is we're saying, so this is some Jinja 2 syntax. So we're just opening the template file here and then making a jinja2.template just by reading the context of the file in. So this is just a Jinja 2 object. You don't need to know the details as to how this works. And then we open our actual target. So here we did targets plus .tpl. Now we're just opening our actual target. And we're going to write out the results of rendering that template. So we call template.render is when we can actually pass all these keywords into the template. So you might notice that that this sort of matches up. So if I open we've got these keywords, author, date, affiliation, which I guess I got rid of. And then over here we have the heat map file name. So these are what's going to be, these keywords here are going to replace those when we do the rendering. Maybe extra background. Jinja 2 is usually used for like web stuff. So when you have a website where you're using like a Python server and you're generating HTML pages, you usually use it for HTML. So it's kind of like lets Python act like PHP without being horrific like PHP, for those of you who have experience. All right, so I'm gonna close out of that. And so then we have our normal syntax for defining the actual task dictionary. We have the actions. And notice how we don't have to explicitly tell this that the target's parameter. So remember up here when we did the special clean function, and we gave this a parameter, we had to do this this tuple with a list. We don't actually have to do that. We didn't have to do that either for the heat map, because it knows, because those are automatic variables, right? So we don't have to give the function arguments, because it just knows that it says, oh, okay, dependencies and targets, I know what to give, I know what to pass to it. So we have the same thing down here, where we're just saying do build, and then it just gives it targets as an automatic. And then here, for the first time, we actually have two file dependencies, right? So our list, it actually makes sense here to have a list. We have the heat map that we're going to put in, and then the template itself. So now this is basically telling us to run. This essentially is now implied that this task depends on both the heat map plotting task and the download task for the template. And it'll figure that all out in the background. And our targets is just the markdown file that we'd actually defined right here. And we've included a clean attribute. Okay, so now if we run it, have another task, did the period to say that it had to run it. And then of course demonstrate, do it again, it doesn't run the second time. And so now if we take a look at what it actually produced, it was this document.markdown.md. And you can see that things were replaced in here. This time it was just your name. And then here is the file. So this is really, really nifty for doing all sorts of reproducible workflows, because you can actually use this to, like, you know, right here it seems kind of silly because these file paths would just be hard-coded, but it lets you do something like update all the tables in your paper. So if you have different data, you could actually fill in the tables with data from your analysis, so that you could regenerate, when you redo the analysis with different inputs, it'll just regenerate the paper itself. So useful things. Okay, so we have our template, we have our that produces our markdown, and it's rendered into its final form. So templating isn't specific to Pydoit, of course, but Jinja 2 is very useful. So if you want, you can try playing around with the template file. So that's just the .tpl. If you add your own content to it, you can see how to maybe add additional fields and stuff. Well, you don't. If you want to, you can do that now. I'm not gonna do that as like an actual in-class assignment. But you might, you know, for an example, if I messed around with the template, might actually not entirely work because DOIT's going to notice that we messed around with the template. But so if I, let's see, what would we change here? I don't know. If I said, no. Something like, author is a graduate student at affiliation and does very important things. I've added some more fields there. Now if I open up my do, conveniently I already have affiliation that I'm passing to it. So for me, I could just change this to UC Davis and change this to my name. Now if I run do it again, I'm gonna rebuild the markdown file. And now, hopefully, if I open that re-rendered markdown. Camille Scott is a graduate student at UC Davis and does very important things. Hopefully you're convinced. Okay, so, all right, so what we've gone over thus far is basically most of what you need to do the vast majority of workflows. We've done, our script could do some refactoring. For example, we have all of these kind of built-in variables everywhere, which might kind of hurt your brain a little bit. You know, we got like, oh, data and data URLs, what we're accessing is global. We could do some work to refactor all of that, but we'll leave that for as an exercise to the student. But this is essentially using what we've gone over. You could basically do your whole analysis using these methods. So the last section is pretty advanced. At first I thought maybe I could do this in a more intermediate way to stick with the original workshop description, but it ended up being pretty advanced. So for this last part, definitely don't, you know, if your head starts to swim, that's totally fine. So this is, because I had originally said, you know, we're going to go over a little bit how to use this for making your own applications. So this is going to be pretty advanced. Maybe some people will really care about this. So the first part for the advanced section is just to finish off the pipeline. So we only have one more step, and that is using pandoc. So we're going to use this to kind of motivate what DOIT is actually doing in the background, and then to get into more of the advanced usage. So the first thing we're going to do to motivate things is just add this last command. So I have a task. I just called it pandoc. I can, I need a shortcut for this, for set paste. Okay. Add pandoc. But the only thing I've really changed here is that might look kind of new, is that I've added command as just a string that we defined ahead of time because it got kind of long. And this is just some arguments to pandoc. This is going to look a little obtuse if you're not familiar with pandoc, but this is just some extra functionality to give to our markdown document that lets us render something kind of pretty. And then we give it dependencies and targets. So the dependency is going to be the markdown file, and the target is just the PDF. So and we have our actions and our clean and everything. So for me, if I run this, it's going to work fine. Pandoc thinks for a little bit, and we're going to end up with a PDF. For many of you out there in the audience, you're not going to have LaTeX installed, and pandoc uses LaTeX to produce its PDFs. So if you have LaTeX, you'll get something like this. It's all official and sciencey, and it's got our thing in it with a little. It's got our heat map in it with a little caption and everything. So what if you're like, oh gosh, I don't have LaTeX and I don't want to sit around waiting for the 4 GB of it to download? Well, it'd be nice if we could somehow like pass a command line option to it. Right? If we could say, here's a command line option to decide what the output format of the document is. So there's 2 ways to do this. The first is you could use, is that DOIT has a built-in functionality for this, where you can give arguments to tasks. It's a pretty verbose syntax. And there's a lot on it in the actual, there's a whole page on it in the documentation. But I personally am not a big fan of the way that the arguments get passed on the command line. It can be really confusing, and it's really easy to mess up. So, and we're also going to use this to motivate using the DOIT library in your applications. So the second way would be is actually also a little verbose, but not so verbose once you get past the boilerplate, is you could specify your parameters with arg.parse. So if you've done some Python scripting, you might have used arg.parse. It's a really nice standard library module that lets you make pretty command line applications. And so what this is implying is that we're not going to use the DOIT command anymore. So instead of using the DOIT command, we're going to actually just write this all as a script and then use DOIT in the background to execute the tasks. So at first this is going to, so this might seem a little weird at first, but we're going to talk a little bit about how DOIT actually creates the tasks and executes them. So usually when you run DOIT on the command line, it's going through, it's looking for the dodo file. Like we said before, if you just run it without a dodo file, it can't find the file, doesn't work. So basically what it's doing is the task, there's a little class called a task loader, and the loader goes through the file, goes through whatever file you give it. It looks for all of the functions that start with task underscore, and then it grabs the dictionaries from them, and it actually makes them into this internal object called a task object. So of course, if you weren't using DOIT, if you weren't using the DOIT command and didn't make these into task objects, they'd just be dictionaries, right? They wouldn't do anything. However, we can actually do that manually. So there's this little function that's a part of the library. That's a dict to task. So what this will do is it'll take a dictionary and it'll create it into, it'll make it into a task. So the simple way to use this would just be to use the dict to task directly, right? We could just call dict to task. We could say something like this. Dict to task, task download data or some such. Task unzip, right? And I would take the dictionary, make it into a task, and then I could say, the unzip task equals this, and then do something with that task. And unzip task is actually a task object then. However, this is a perfect opportunity to use a decorator. So I know the decorators are kind of beyond intermediate. Has anybody used decorators before? All right, so decorators, you might have seen the syntax in the past, but decorators basically let you add additional functionality to your functions without changing the functions. So the decorator, what it does is it takes a function as an argument and it returns a new function. So in this case, we're saying we want a function, which for us is just going to be something like our task function. So say task hello world. So it's going to take that, and then it actually passes that function to another function, does something to it, and then returns the function in the end. So do not be alarmed if this seems really odd and weird. For now, we're just going to use this code, and we're just going to continue on and
is it like recursion?
No, not exactly, but kind of. So this is relying on, I guess if we have a little bit of time, I can give an extra advanced Python lesson here. This is relying on some Python operational semantics, I guess, where or even functions are objects. So everything in Python is an object. Everything is a reference. Everything can be modified on the fly, including functions. So what you do, so just to show you you actually make use of this, is it's this syntax. You do this @ sign. Maybe you've seen the @ signs if you've been looking at other people's Python codes. So that's actually what decorator is. And so basically what this says is it tells Python when this function gets executed, or when this function gets defined, I should say, it should then be passed to this function to make task. So it says, okay, do it at make task. The function itself gets passed in here. And then within this function, it gets passed to another function. So this seems odd, but it's basically we're making a new function. We're making a new function which calls the original function. So it says call the original function, save the result, and then return dict to task on the result. So this function doesn't get executed right away, right? It just gets defined, and then we return it. So it's saying convert this function into another function. So that's some advanced Python. You don't necessarily need to entirely understand how the decorators work to make use of them. If you want to write your own decorators, then of course you need to go and dig a little deeper and see exactly how they work. But we're just doing this so that we can avoid a little bit of verbose syntax. Okay, so what we're going to do is we're going to use the decorator to decorate all of our task functions. So remember, this time we said we're not going to use DOIT. So we have to do this because we want our functions to actually be turned into tasks without using the DOIT command. Okay, so the other little piece of boilerplate we have to do is we actually have to make our own loader. So this is also going to look kind of confusing. Conveniently, this exact code is basically just riffed from the DOIT documentation. So they kind of tell you how to do this. We have a second piece of boilerplate to actually run the tasks. What this is doing is it's just another little function, takes a list of tasks, a list of arguments, and then some config. You can kind of ignore this for now. And then it actually defines a new loader, which is based on one of DOIT's built-in classes, the task loader. So the task loader is what usually gets run when you actually run DOIT to go and find all the tasks. And we've just overridden the very basic load tasks method and just chosen to use our own tasks instead of finding them from anywhere. So you could also write your own loader if you wanted to just like, you know, if you wanted to pull tasks from any unusual places. If you said like, I want to traverse everything in my current Python project and find every task and then run all of them or something, right? Which there's some cases where you might want to do that. Then it's finally DOIT main is just the main driver. That's usually done in the DOIT command, and then we're just passing the loader to it and running it with the arguments. Okay, so that's probably not entirely clear. If you play around for a little bit, it might make some more sense. And just recall that this is advanced usage. So this is definitely not the canonical way to run your DOIT tasks, but it's really useful if you want to like write your own software as opposed to just relying on DOIT. Okay, so what I say here is if it all seems a little obtuse, don't be alarmed, because this is just basically those two pieces of boilerplate are most of what you need to start writing your own applications with DOIT. Okay, so we're just about ready to actually create our application. So what I'm going to do is I'm going to create a new file called myapp.py instead of dodo.py. So conveniently, I've already downloaded it. And so basically what you can do is just copy and paste all of the tasks from your old thing, from your dodo.py. You can also just go and download it at the end, because I recognize that this got pretty advanced and it would be easy to make a lot of typos and get things screwed up. So there is a direct link to the myapp.py here at the end. So what you'll want to do, what you would do if you were just copy and pasting this, is you would just go through and you decorate all these tasks with the make task, decorate all these functions so that we know that they are supposed to be tasks. And then what we'll do, so we have this pandoc task, is the final piece to make this into our own little script. So we're going to define a main method, just because main is a nice name for these things. we import arg.parse, and you might recall that our original goal was to be able to specify the extension for this file. And so we just added one argument to it, out format. The default will be PDF. And then, instead of relying on DOIT, we're actually going to just manually create our tasks. So if I do tasks as a new list, I start appending tasks to it, and I actually call the functions here. So usually DOIT would call the functions for us and take care of all this, but we're actually just going to call the functions manually and explicitly. And at the end, we use our other piece of boilerplate, the run tasks function. We pass the list of tasks to it, and we actually pass explicitly run. So usually on the command line, you could actually do it like this. You could just say, you could do it like this. You could say DOIT run. DOIT run is this generally the same as, yes, it's finding some other stuff now, so that's okay. But usually that's mad because I added the my app.py to the directory. But generally DOIT run would be exactly the same. It's just saying do it. I must have edited this. Yes. Yes. Cranky because I decorated the task function and then DOIT tried to redecorate it, make and do it in another task, and so things got strange. So usually if I just did DOIT run, it's the exact same thing. It's just easier to write DOIT. It's kind of the default state. So now if I actually wanted to run this my app script, remember we've got my app here. I could do it like this, Python my app.py, which would do it on its own. Redo all the things, running the tasks, plotting, pandocking, etc. Or I could say -- out format md, and it redoes only the pandoc command because up here I just slightly modified the actual command, the actual task, to take an extension. So now I have pandoc task actually takes a parameter, and then I'm just changing the target slightly. So down here, when I actually create the task, I'm just passing that parameter from arg.parse. Now, if you went through and just decorated everything and try to do this without downloading the file, it's actually not going to work. The reason is because we had that yield. Remember we had the generator object for the download? So we had to make a change there. So let's compare the two. So originally we had this download data. We've got the yield going on, and it's just going through the data URLs and just yielding each task. But this doesn't work with a generator. There's ways to make generators work with, or to make decorators work with generators, but for now, you're probably already confused enough by introducing decorators. So we're just going to get rid of this, and we change it to a non-generator version. So what this does is now we're saying, all right, let's let this function just take a URL and a target. And by default, the target's none, and then if it's not passed, we just make the target based on the base name. And curious, you can actually use os.path.basename on URLs because they follow the same format. So Python knows what to do. So all the path manipulations from the OS module can actually just be done to HTTP, whatever URLs as well. So this
That's still work on Windows?
should. I don't have a way to test it currently. Actually, I guess I could test it on my home computer, but I have not. So here, we're just doing with a name, and then just returning this one task. So now, instead of having the yielding subtasks, we just go down here, and I changed this so that we iterate through the URLs here. and just add 2 tasks to our list of tasks. So the final thing is it's still not going to work because it turns out that when you do it this way, it doesn't have none of the tasks end up with name attributes. So what you have to do is you have to manually add name to each one of these. So here I just called it like name gunzip. And I think under the hood it's because it starts turning all of these into, it starts considering all of them like subtasks. So usually when you have your own, usually the task loader by default will just go in and pull a name off of the function name. But because we're not doing it that way, it needs to have a name. So I added names to all of these. This one's just called gunzip. This one's called plot. You could also name them something like, you could say like plot, melee data.csv.heatmap.pdf, name whatever you want. And so now that's essentially, you've got your own application, which RSC instead. You now have your own application, which can just run your analysis pipeline and take as many parameters as you want and define the tasks manually. So those are two ways that you can actually interface with your DOIT tasks. So of course, and then actually if we want to look at, take a look at what it actually output, we said this .final.rst, this one, so this is the same thing because Pandoc is really awesome. This is the same thing in restructured text format. Here's the same thing in Markdown that it created. Obviously, it didn't really do much of a conversion there because it was already in Markdown format. Do melee data.final.pdf. Actually, I can't really edit that in Vim. You could also, Pandoc can do a whole bunch of formats, so I could say something like, maybe this will work, I don't know, EPUB. I guess so. Can I open that actually? See, look, it actually opened it in iBooks, and that isn't it? So there, it actually even can do EPUB. So I'm surprised. I did not expect that to work. So fun. And there's some. There you can see my book collection. It's reading the Mars trilogy. So, and that was all just by just making use of our little command line script. So I know this final section was probably a little confusing. There's a lot introduced. So this exact script with the working code is here at the end. And that's all the basics and some extra advanced usage of DOIT. So there's some other things that we didn't go over. We didn't go over task dependencies. We didn't exactly go over task arguments. We didn't go over the parallelism. So there's a whole bunch of extra stuff here with DOIT that you can go look at the documentation for. You can give your tasks titles. So the title attribute is doesn't actually change the name of the task. It just changes the way that it displays. So if I did like my title could be something like, I'll do the doo-doo this time. So title, I could say this. Should. Oops, it's supposed to be. Yeah, sorry. Function title is supposed to be a function. And I don't think it could be a lambda function. But if I did, so here's the example they give is that you just define this simple little function. And they're saying they're just pulling the task name off. But if I said something just like hello, I can just give it as function. And it, instead of saying the task name, it says hello. I also have some built-ins for naming it, for formatting the titles in certain ways. Yes, there's a lot of extra stuff here in the documentation. The documentation is really nice, but it doesn't bring you through an actual pipeline. So hopefully between this, between the materials here and between the documentation, you'll be pretty set to go. And that's all I've got. I'm going to stick around here until noon for extra questions. If you're online, you can tweet things at me. I guess I didn't put my actual, my Twitter handle on here. But here you can see another bit of live updating. Here's a restructured text syntax for you. Created by Scott. GitHub.com/Camille Scott. You can tweet questions at Camille Coda. Do something like questions, and we'll say at Camille Coda. I think that should work. Build HTML. So here's another DOIT file. That's fun. All right, so there's some warnings there, but hopefully just testing it out. HTML index. Oh, see, I screwed up my syntax for one of them. It's a danger when you're coding things live. Yeah, look, somebody's already tweeted at me. Yay. Okay. Somebody thought it wasn't horrible. Thanks, Lex. Push my changes. Hopefully Titus is watching and he'll be very proud of me for all this GitHubiness and everything. And then I'll push up the changes to the website. Okay. Cool.
I do have a question, sorry, I walked in late. You might have already mentioned this.
The people on YouTube don't know.
Does it matter, so when you're constructing your tasks, so each task is in a function.
Yes.
Does it matter what order they're in?
Yes, okay, so it can matter.
Can you repeat the question?
Yes, so the question was, does it matter what order the tasks are in the file? And the answer is sometimes. So the order matters when the tasks don't have any dependencies, right? So usually it's going to use the dependencies to build the kind of flow chart of when the tasks are executed. But if there are no dependencies, it will just execute them in the order that they're encountered. So yes, but if you were to define all your tasks backwards in your file, and they all had file dependencies set up, it'll still execute them in the right order. So it's only if they don't have dependencies on other tasks or files. And that's actually the goal of the task dep, which actually, I guess I can, maybe a little time, so I can actually demonstrate, demonstrate how to do the task dep live because we've got a little bit of time. So that's actually, and that'll actually answer Jim's question from earlier. So if I open up my do, let's do it with the, let's see, we'll do it with the hello world task. So hello world doesn't have any dependencies, so it just kind of happens whenever. So hopefully, so now if I were to move this to the bottom, say, it should execute last. It's dangerous. You might catch me lying to you. Okay. So we moved it to the bottom and it executed last. If we move it to the middle, it should execute in the middle. So it's in the middle. However, if we want to enforce a particular order without making dependencies, so say I always want hello to happen last, but it has no dependencies, and I don't want to necessarily, you don't want to necessarily rely on the loader finding them in the right order, because you might have tasks spread out through different files. Sometimes they might be generated dynamically if you're trying to give them some advanced stuff. So you might want to actually enforce some ordering. So if we do this, we say that where's my hello? This is where I can do a task dep. So I'll put it here. So task dep actually lets us rely on a specific, it says, do this after this other task. So you use the name of the task. So let's say we want it to happen after the pandoc task. The name of this task is just pandoc, because it doesn't include the task underscore part. So I can say the task step is, and I think it needs to be a list. So if we do like this, task step is pandoc. These work. Yes. Now it goes last, even though it's defined in the middle. So it's important to note that the task step has nothing to do with whether it's up to date. So if I remove, see, whatever the result of the pandoc, which file is pandoc outputting right here? Document.pdf. So if I remove rm melee data.csv.document.pdf, which is saying the pandoc is no longer up to date, the pandoc task, this one. If I run it again, pandoc runs again, but hello does not. Because the task steps don't have anything to do with the up-to-datedness. They only enforce order. Does that make sense? Okay.
So all that's doing is just changing the way the DAG, right?
Yes. Yep. Changes around, kind of enforces some directionality. It enforces ordering through the directed acyclic graph without requiring any kind of, without having the up-to-datedness look at it all. Yes, exactly. Any other questions from Twitter? Yes, you did, Lex. He was on the podium. Cool. So yeah, and I'm also going to go, seeing as we found some typos throughout, I don't know if anybody took notes on them. I think excellent. So I'll go through and fix. There was a couple typos in the materials that I'll make sure to fix for you. Always the danger of making your own materials is that or write tests for your workshops, but
Or just discover them while you're teaching.
yeah, you get to impress everybody with how quickly you can live code things, or something like that.
Exactly.
I
Okay.
had a question for you, Camille.
Sure.
On the last bit, the advanced part, we were making a do application.
Mm-hmm.
It looked like you had to build the DAG yourself. Is that true, or?
It's actually not.
It's not?
So yeah, so I did, so you're talking about here where I'm appending them in a particular
Exactly.
order. So I could actually change that around to any order.
Oh, okay.
So if I'll just demonstrate. So if I did like this, it should still work just fine. Still executes them in the same order. So the ordering, so for the application, but say with like the thing where we had them being executed in the order they're encountered, this order that we do the appending in would matter if there weren't any file dependencies. So the same way as how the DOIT loader encounters task functions and executes them in that order, same thing for this list. You also might be, so it's like when we have an application like this, you might wonder, okay, how do we like make DOIT do its other functionality like cleaning? So you could either explicitly define your own, extra like positional arguments. You could say something like parser.add argument, DOIT CMD. Say this is going to be DOIT CMD. That way, if I said, and then I'll do this so that it's at our little hash bang. Serve in Python. Why? Right, so now I could say /myapp.py. It's not going to work because I didn't tell it the DOIT command. So if I said, /myapp.py run, should actually, sorry, did a typo there. args.doit command. So this came from the arguments, remember? So args.doit command. Do it this way, now it's going to run. I could also say do it clean, please work. Yep, cleans. I like it when things work. The other way you can do this to really get basically all access by default is you can make use of some arg.parse functionality, where I could say parse known args. So what that'll do is it'll put, and let's see, this is going to be args, and then it'll be DOIT args. So the parse known args says parse everything that we've defined here into the first arg list, and then all the ones that we don't recognize, save those too. So what I'll do is I'll say, we'll do our normal args, and then I'll just pass the DOIT args. So that may or may not work. I'm not. Let me double check here because I'm not sure that DOIT args actually ends up being a list. I do myapp.py run. Yeah, it does amazingly still work. And then I can probably do all of my other DOIT args where there's things like threads. Yeah, maybe not. I'd have to do some more playing around, but you can just pass, your normal arbitrary DOIT commands to this run here. So if I did like a run like -- threads, that'll work. Oops. It's definitely not going to work if I do the wrong syntax. Boy, it wants that before the run. Sometimes it's kind of picky about the ordering it gets things in. Maybe the developer will tweet at me and tell me to stop teaching people how to do this incorrectly.
You have to have run after.
I'm probably just using the wrong. So like -t. I think I'm just giving it the wrong. Let's see, parallel. -n -process. Yep. So I'm just using the wrong actual name. If I did like a. And this is just -n. So you can just pass any of your normal DOIT arguments as a list. And that is actually a fun one to play around with, as if I did a DOIT clean. So now remember, I'm running off the do file here. And then I said clear. So now there's a lot of other commands, like I say, like DOIT list tells you the list of tasks. You can actually just execute one task at a time. So I said, oh, I only want to do hello world. Oops. It will apparently refuse to obey my commands. Oh my. I think I might also be getting confused because I have these extra. Yeah, so the reason I did that, okay, so it actually did work perfectly there. Remember we added the task step to hello world?
Oh.
So it said run hello world only after all of the other things. And so I said only run it after pandoc. Well, if I run it after pandoc, I have to run all of pandoc's dependencies. So that actually just runs everything. So if I do it clean again, I'll do a better example. So I do it list to see what my tasks are. And say, let's just do it gunzip data. That should only, yeah, so it just downloads the file and gunzips it. So you can do single commands. I can also say do it -n2. It'll do 2 in parallel. It'll do as much as it can in parallel. So it uses the Python multiprocessing library, and it will run several at the same time. And it uses the directed acyclic graph to figure out which tasks it can actually run. So this is useful for it's useful if you have like access to some big machines with a lot of processors. You know, if you're like on a supercomputing environment or something. It is kind of limited because it can't talk between nodes. So there's no wrapper right now to like talk to another node on a supercomputer and like spin up, 1,000 tasks or something. There might be a plugin for that somewhere, though I haven't actually looked. That's not something I've looked at extensively yet. But maybe somebody watching the broadcast will, decide to go write a plugin to do that. Hint, hint. Yeah. So any other? If you look at your DOIT help, you can see, there's a lot of. You can actually look at more info on individual tasks. I can say DOIT help gunzip task. Show help. I don't know. I didn't actually DOIT help download task. Curious. I might be using the wrong names. DOIT list. Zip data. That's why it's not working. DOIT info gunzip data. That gives me some info on the actual task. Same with help. Should do something similar. Yeah, not a lot to say about that. Oops. DOIT auto. I've never actually played around with DOIT auto before. It seems like it would be useful. It'll run it as like a little server in the background, and it'll re-execute everything once a dependency changes. So you could just like have it running in a directory, and just if you're like putting new files in the directory, it'll rerun everything as it gets new information. You can force it to ignore tasks. You can force it to reset the dependencies on tasks. So there's a lot of extra stuff going on in the backend that you can play around with. You can even do this. You can do a tab completion. And then, if I remember how to actually do this, let's see. You do source generated scripts. I don't know. Let's see if it actually. So if I say DOIT tab completion, this is fun if you're like trying to run things as an app, and then I can say, tab if I source tab, that should let me allow. So it gives me tab click. So I say do it GU and then I press tab. Okay, I guess it probably doesn't work on Mac properly. But that's fun if you're on a Linux system. You can tab complete the task names. Yeah, so there's a lot more to look at in the documentation, and as I said, it's very well documented. So, all right,
Thank you.
you're very welcome. Are we still
Yes, we are.
off there?
We are on
All right, well, thanks everybody for watching.
Wait, let me. Well, thanks for watching, everybody.